Okay, this is a video about evaluating functions. The last video talked about what a function is. Now we're going to look at a graph, an equation of a graph. Y is equal to 2x plus 4. Hopefully you guys know how to graph this. This is a graph that has a slope of 2 that starts at a y-intercept of 0, 4. So if I graph this, it goes up 2 over 1 and up 2 over 1. So it looks like this. This line right here. Now, you guys should agree with me that this is a function. The last video stated that as long as the graph itself passes a vertical line test, that means that there's only one y value for that x value. It's a function. There's a way to write this. Instead of y equals, you're going to start seeing, and you might have already seen, function notation. Okay, so I'm going to write that up here right now. So function notation is basically, instead of a y, this will turn into f of x is equal to 2x plus 4. So the only thing that changes is this. It's the same thing though, okay? This does not mean f times x. This just means the function with respect to the input variable, which is x. So it's telling you that x is the input variable. Okay, so that's very important. So you're going to see a lot of different functions. So I'm going to write a few functions up here. So a function f, that's, I don't know, x squared plus 2x plus 3. Let me do another function. Sometimes if we're using multiple functions in a problem, they'll change the letter. So this function with respect to x is f. This one is g. And I'll just say that this is 3x plus 5. And why don't I put one more up here? I don't know. Let's do x minus 2. Okay. So there are my three functions. It's like me saying y equals that, y equals that, y equals that. You can graph them as three different lines, but this is again function notation. And this helps us evaluate functions. So I want to know, so we're going to use all three of these things, and I'm going to just come up with some problems. So my first example is I want to know what f of 2 is. Okay? That does not mean it's f times 2. It does not mean I'm multiplying this by 2. It means that instead of the x, I am now putting a 2. That is my input value. So everywhere you see an x in this equation up here, we're going to put a 2. Notice everything in black is not changed. The only thing that is changed are where the x's are. So f of 2 means figure out what happens when you plug 2 into this equation. It's very simple. The thing you have to be careful about again is the notation. So if you do this, you get 4 plus 4 is 8 plus 3 is 11. So the answer is 11. Okay? Let's do a couple more. We're going to just keep using these three functions up here because it's easier for me than rewriting them out all the time. So example 2. Let's say I want to know what g of negative 2 is. Okay, so now that's telling me I want to evaluate the g function. So I go over here to g, and I have 3x plus 5. So the 3 stays the same. The x turns into a negative 2 plus 5. That was supposed to be a different color. All right. So if I evaluate the g function with by inputting a negative 2, I get negative 6 plus 5 is negative 1. Let's do one more with just basic. I'll do it over here. I want to know what h of, I don't know, negative 3 is. All you do is put a negative 3 where you see an x, and then you can solve this. So h of negative 3 has a value of negative 3 minus 2 is negative 5. And again, this is not saying I'm multiplying h by negative 3. It's telling me for the h function, I input a negative 3 for x. That's what that means. All right, so we can also do a couple of other things. What if I say, we're going to keep using those up there, so keep those in mind, maybe write them down, or I'll keep writing them down. We can also add and subtract functions. So what if I want to know what g of 2 is plus f of negative 1. Okay? So I'm going to do that. I go to the g function first. That was 3x plus 5. So we get 3 times 2 plus 5. And that's the first function. Plus the second function evaluated at negative 1. And you can do these separately too if you wanted to. I'm just showing you how to do it in one big equation. So this turns into a negative 1 squared plus 2 times negative 1, because again we're putting a negative 1 in, plus 3. Okay? So if I want to know what g of 2 plus f of negative 1 is, I get 6 plus 5 is an 11, plus negative 1 squared is 1, minus 2 is negative 1, plus 3 is back to 2. So we get plus 2. So that means that if you add those functions together at those values, you get a value of 13. Okay. Now, we can also do values that are, we can just add and subtract with x values. So let's do 2 of those. And then those will be the extent of these evaluating, but I will show you some more advanced ones. Maybe do one of each example. I can do a graph and a list and show you how to evaluate those. First, let's just do what f of x minus g of x is. Notice how I didn't put any values in. That means I just want you to subtract the two functions. So f of x, again, was x squared plus 2x plus 3. So x squared plus 2x plus 3 minus parentheses 3x plus 5. Again, when you are subtracting functions, I cannot tell you guys how many times everyone forgets to distribute this negative because they forget the parentheses. We are subtracting the whole function. Okay? So note that. So, if we're subtracting this, this just becomes, I'll just rewrite it out without parentheses. This stays the same. Distribute the negative. And that's what it turns into. And now you can simplify this. We have x squared. 2x minus 3x is a minus 1x. 3 minus 5 is a minus 2. So if you subtract f of x minus g of x, that's what you get. And now you can actually plug in if you want to know, well, what happens when I want f of x minus g of x at 3? You can then plug a 3 in and evaluate. Okay? Alright. Now, those are the more basic ones. I just want to show you two other fun ones. Graphically, this is going to be more pre-calc. We do, I think, a little of this in Algebra 2 as well. But let's say I give you a graph, and I give you these points. Uh, 3, 1, and put a point there. 5, negative 1. So I just have some random function here. I don't care about all this stuff. Okay, so that's my graph. It doesn't go vertical, it's a function. So that's my graph. And I want to know from this graph, I want to know what is, and we're going to call this graph f of x, by the way. So this line is the graph of f of x. I want to know what is f of 5. Okay? You don't need an equation to do it, you just need to know the points. Do we know what the y value is when x is 5? Because that's what they're asking us. They're asking us, what is the value of the function of f when x is 5? So if we look at it, we can see that when x is 5, the value is negative 1. Okay? So that's graphically what they're telling you how to do there. Alright? It's as simple as that. One more that I want to do, and this kind of goes back to the list we did before in the last video. If I give you the values, that this relation, that these ordered pairs that represent functions, and let's do another one. Okay, So you guys should be able to agree that this represents a function, and this function is going to be called, we'll just call this function f. Okay. Or these are points on the function of f of x, if you want to call it like that. So, even though they're just points. So, you might see something where you're given a list, and then again, you might be asked to evaluate what is the value of the function that's given here at 7. And again, you look at all your inputs and go, well, when x is 7, the y value is also 7. And that's all you have to do. It's that simple. Okay, so that is how you evaluate functions. Plug the numbers in, and hopefully you understand function notation. That's the thing that's most important. I don't want you guys thinking that you are multiplying the thing in parentheses. You are just inputting for that. Okay, so anyway, that is evaluating functions.